we're going to do is we're just going to analyze more about the graphs, guys. So to find the possible number of real zeros, the possible number is equal to the degree. So if I have a polynomial to the 8th degree, there's a total number of 8 possible real zeros. If I have a polynomial to the 1000th degree, there's a possible number of 1000 real zeros. And remember, real zeros really do cross the x-axis. Turning points. The turning points are exact. So the first little bullet here is possible. This is exact. So if the degree is 7, then the graph turns exactly 6 times. If the degree is 1000, then it turns exactly 999 times. This is exact, that's possible. To find the zeros right now for us, guys, we're going to factor. Again, that's why factoring is so important. So we're going to go a little bit out of order. If you could please turn the page and look at that. That's at the top of the other page. I'm going to write something right here. You write that at the top of your page. So right here, guys, all I'm going to draw is the x-axis because the x-axis is important. The y-axis, we don't care too much about yet. But the x-axis is super important. So remember, today we're graphing polynomials. And polynomials are a bunch of monomials stuck together. Some of them have been added together. Some of them have been multiplied together. When you have a bunch of monomials being multiplied or added together, things start repeating. And that's what happens. That's what this is explaining to you. Sometimes you'll just have something that goes straight through. Draw that. That is not a repeating zero. That is not a repeating monomial. Then you'll have something that might repeat 2 times, might repeat 4 times, 6, 8, 10. What are all those numbers that I'm throwing out? 12, 14, even. If anything repeats an even number of times, it bounces. And we call it tangent. It could bounce up or it could bounce down. But wherever it came from, if it comes below the x-axis, it's staying below the x-axis. If it's above the x-axis, it's staying above the x-axis. Then something could repeat 3, 5, 7. What kind of numbers are those? Odd. If it repeats an odd number of times, it has a change in concavity. And I am horrible. Like, that's pretty good. I'm pretty proud of myself drawing that change of concavity. Most of the time, I'm horrible, but I'm going to get full credit on tests and quizzes because I'm labeling it. So this stuff has to be labeled. We're going to do that the second half of the lesson, but I'm going to go ahead and point out the repeats because they already start happening for us back on that other page. So flip back over. We'll go back to that later. Let's flip back over. Now. All right. So what we're going to do is we're going to find the possible number of zeros, the exact number of turns, and then we're going to factor. So number 1, the degree is, or 1a, the degree is 4. So that means I might have a possible up to 4 real zeros. Certainly not 5, but possibly up to 4. But I know the exact number of turns. What's the turns? What's 4 minus 1? The graph turns 3 times on the coordinate grid. All right, we're going to factor this. Is there a GCF? X to what power? That's a repeating 0, guys. We're going to have a multiple 0 happening there. Let's go ahead and factor out the x squared. So inside the parentheses is going to be x squared minus x minus 20. Write that down. As soon as you close that parenthesis, you should recognize what the factors are for that. That's how quick you need to be, guys. What are the magic numbers for this in here? Very good. -5, +4. So x minus 5, x plus 4. All right. We have factored that completely, which means it has real x-intercepts, guys. So let's talk about the zeros. X is going to equal That 0 right there, remember when you factor out a single monomial with an x, it goes to the origin. So that's a 0, comma, that's a positive 5. And then, of course, the other one is a negative 4. However, starting now, you have to go back and address the multiplicity. So, I'm just checking to see if I have my pen set up right. I don't. I don't know where that went. That's always nice. So, I'm going to draw a little arrow out to the side. And I'm going to write the multiplicity of 2, but I'm abbreviating. Multiplicity of 2. How do I know it's a 2? Because it has an x on it. That's all that is. That's it. All right, guys, what is the degree of this? Yeah, it's 5. So possibly it's going to cross the x-axis up to 5 times, but we know exactly how many turns it has. 4 turns, that's right. And those turns will make sense once we start graphing it. Do you have a GCF? X to the power 3, which means you're going to have a multiplicity of a 3 in a minute. Let's go ahead and take out that 3. So that's going to leave 2x squared plus 11x minus 13. Let's see if that's going to be factorable. I'm going to be sliding and dividing. Alright, so it is going to be a negative 26, but we need it to add up to an 11. Does that exist? Yeah, it's the numbers we just used. But we're going to make the 13 positive and the 2 negative. And don't forget, we have to go back and divide. All right, so we have 3 factors. Remember, you have that x to the 3rd. Then you're going to have 2x plus 13. And then remember, that's x minus 1. So those are your factors. Here's your zeros. X is going to equal 0. Negative 13 halves, leave it as an improper, it's fine. And then positive 1. But you have a multiplicity on which one?
0.
The 0. What is the multiplicity?
3.
You guys know the hard part already. Good job. Write MO of 3. And then, guys, I need to box in my answers here. Okay, let's keep moving on. Letter C is going to have a degree of what, guys? Right, so you can have up to 4 possible zeros. We know that it turns exactly 3 times. Y'all, is there a GCF? There's not. But when we factor this, you have 4x to the 4th power. You have to distribute that right in half. So when we draw our parentheses, you have to split them evenly.
I was going to ask if like, it's a fraction.
Go in there. Negative 4. And then what? Yes. So, can y'all keep factoring that? What is that?
X plus 2
And then, that's imaginary, guys. So if I tried to solve that, it would be x squared plus 1 equals 0. Move that 1 over. I'm trying to take the root of a negative number. Impossible. Hold on. I'm trying to take an even root. Anytime I try to take an even root of a negative number, that's imaginary. So the only real answers that we have, the only times it really crosses the x-axis is at the positive 2 and the negative 2. So x equals positive 2 and negative 2. Those are the real zeros. I don't even care about the imaginary right now. I will. Those are important later, not this week. So box that in. All right, letter D. What's going on with letter D? How many possibles?
3.
3. How many terms?
2.
Is there a GCS?
Yes.
Oh, what does that tell you? It goes through what?
0.
It goes through the origin. That's right. So when we take out that x, we're going to get x squared minus 6x minus 27. You can certainly keep going on that. Write MO on anything because there's no exponent when I get to my factors. So x is just going to equal a plain old 0, a plain old 9, and a plain old -3. That's it.